Okay, we want to graph a rational function, and we're given a quadratic over a linear. So the first thing I need to do is long divide. And this particular problem has some pretty ugly coefficients. What that means for me is that I am going to write my steps over here so that I don't make a careless error. So 4x squared over 6x is equal to 2/3 x. And that gives me 4x squared, then 2/3 x times 9, right, this times this, is equal to 18 divided by 3 is 6x. And I'm going to subtract all of that, 6x, and bring down the next term. 6x divided by 6x is 1. That's a blessing of sorts. Oops, do that correctly. Okay, and then I subtract all of that and I get negative 6. And so I have negative 6 over 6x plus 9. And yes, that fraction simplifies, but I don't care about that fraction. That's the part that that never quite becomes 0, and so it creates our slant asymptote. Our slant asymptote is y is equal to 2/3 x plus 1. So you have to be able to graph a line. 2/3 x. Okay, and then if 6x plus 9 is equal to 0, then x is equal to negative 9 over 6, which is negative 3/2. And that is my vertical asymptote. And I'm going to move this up here where I can just see the original function. So my slant asymptote has a y-intercept of 1 and a slope of 2/3. And my vertical asymptote is at negative 3/2. Well, try to make it a little even. Negative 3/2, that's negative 1. Oh, that's nice. Well, that's a little more like negative 2. There we go. No, well, there you go. Something like that. Okay, they do, those two asymptotes do intersect at negative 3/2, 0. All right, if I put a negative 3/2 in here, that's negative 1 plus 1 is 0. And now I need to find 2 points on either side of the vertical asymptote. And here's the reason for that. I can't have, oh my God, I didn't just, oh, yeah. There we go. I can't have a piece like this and a piece like this because that wouldn't be a function. That would fail at the vertical line test. So really, all I need to know is which one of those two pieces I have on each side of the vertical asymptote. So I'm going to let x equals 0, and f of 0 is equal to 1/3. Right? F of 0 is 3/9. So that's just 1/3. And f of 1 is equal to 4 plus 12 plus 3 over 6 plus 9, which is 16 plus 3 is 19 over 15. And that's just a little bit more than 1. Now I'm going to move out to the other side of the asymptote, and I'm going to erase my marks here so I don't have to slide down to where I can't see the function. Can't see the function rule. I'm going to find f of negative 2, and that is 16 minus 24 plus 3 over negative 12 plus 9. So this is negative 8 plus 3 is negative 5 over negative 3. That is 5/3. So at negative 2, I have 5/3 is right about there. And f of negative 3 is equal to 36 minus 36 plus 3 over negative 18 plus 9. So that is 3 over negative 9, which is negative 1/3. So at negative 3, I have negative 1/3. And then when I click on the little curve bar, or curve button, it will fill in the graph like this. You have to be able to do all of these steps in order to enter what ALEKS requires you to enter. But if you're struggling with this concept, check yourself in a graphing calculator before you hit enter. You know, put this function in a graphing calculator and hit graph, and set your window size to the same size as the graph you've been given in ALEKS.